Right now, as you watch this video, you're probably sitting somewhere, not moving at all. But even if you feel perfectly still, the truth is very different. Earth is hurtling through space at about 30 kilometers per second, and the Sun is also racing through the galaxy at around 220 kilometers per second, dragging our entire solar system along with it. We don't feel any of this because gravity keeps us anchored, but everything in space is always moving, always flowing, and never remains truly still. What makes entire galaxies move is one of astronomy's most fascinating mysteries, and that is what we are exploring today. As you watch, the Milky Way and everything in our local universe, across millions of light-years, is being pulled through space toward a powerful gravitational focal point we cannot see. Whatever is hiding there influences vast regions of the universe with an almost unimaginable force. This is the mystery of the Great Attractor. The Milky Way, like countless others, is a massive and ancient system containing hundreds of billions of stars. Galaxies this large have strong gravitational pull, allowing them to behave as unified structures and even attract one another from millions of light-years away. Some get close enough to collide, creating entirely new galaxies. But even though galaxies can attract each other, the space between them is enormous, and the universe itself is expanding. This expansion pushes galaxies apart faster than gravity can pull them together. This phenomenon is known as the Hubble flow. Because of it, most galaxies move away from every other galaxy as the universe stretches, and only small, dense regions like our local group are able to stay together. However, even though most galaxies won't collide, dense concentrations of them can still influence one another. They gather into larger structures, drawing in more galaxies and leaving behind empty regions of space. Over billions of years, this creates a massive cosmic pattern called the cosmic web. It resembles a sponge, filled with interconnected filaments of galaxies and giant voids in between. These filaments contain hundreds of thousands of galaxies and can stretch across billions of light-years. Within them are clusters and superclusters, groups of tens, hundreds, or thousands of galaxies interacting through gravity. With decades of mapping and research, we now have a detailed understanding of our large-scale cosmic neighborhood. We know that our local group, which includes the Milky Way, Andromeda, the Triangulum galaxy, and more than 100 dwarf galaxies, sits near a much larger cluster called the Virgo cluster, which contains about 1,300 galaxies. The Virgo cluster is part of an even larger structure known as the Virgo supercluster, but that too is only one small section of an enormous region called the Laniakea supercluster. Laniakea spans about 500 million light-years and contains over 100,000 galaxies. Its structure is so large and complex that we didn't realize all of its parts were connected until about a decade ago. Because Laniakea is so spread out, it isn't tightly bound together by gravity and should be drifting apart as the universe expands. But something strange is happening. Instead of drifting apart, the entire supercluster appears to be flowing in one direction, as if being pulled towards something incredibly powerful. This gravitational anomaly is what we call the Great Attractor. It acts like a cosmic sinkhole, drawing in matter over hundreds of millions of light-years. The strange part is that we cannot see it. The reason we can't see the Great Attractor is because it sits behind a part of the sky blocked by the Milky Way's galactic plane. Our location inside the galaxy makes it impossible to see about 1/5 of the universe behind thick dust clouds and bright starlight. This blocked region is called the zone of avoidance. It just so happens that the universe's largest gravitational anomaly lies behind this hidden area, making it even more mysterious. Scientists first detected signs of the Great Attractor in the 1970s when they discovered that the Milky Way is moving through space at unusually high speed, about 600 kilometers per second, toward the constellation Centaurus. This movement wasn't explained by the expansion of the universe alone. Something was pulling us. But because the source was hidden behind the Milky Way, early astronomers couldn't see what was there. As technology improved, especially with studies of the cosmic microwave background, scientists discovered something called the CMB dipole, a temperature difference across the sky caused by the Milky Way's movement. This meant something massive was tugging at us. But what? Early theories suggested it might be dense clusters of galaxies behind the Milky Way or the influence of the Virgo cluster. But the Virgo cluster wasn't nearly massive enough to explain our speed. So astronomers kept looking. X-rays, unlike visible light, can pass through the dust of the Milky Way, so astronomers used X-ray surveys to peer into the hidden region. In 1996, they found a huge galaxy cluster, Abell 3627, also known as the Norma cluster, located about 220 million light-years away. It became a major candidate for the heart of the Great Attractor. But the Norma cluster alone couldn't explain everything. Something even bigger had to be contributing. In the early 2000s, an extensive X-ray survey called CIZA discovered over 200 previously unseen galaxy clusters hidden behind the Milky Way. But again, these clusters didn't add up to the required mass. Then astronomers looked farther and discovered the Shapley supercluster, one of the most massive superclusters known, located about 650 million light-years away. It contains over 8,000 galaxies and has a mass thousands of times greater than the Milky Way. Shapley turned out to be responsible for more than half of our unusual motion through space. The Great Attractor wasn't acting alone, it was being pulled as well. Then, in 2016, researchers discovered yet another supercluster beyond Shapley, the Vela supercluster. This massive structure, about 800 million light-years away, adds even more gravitational influence to the motion of our entire region of the universe. When combined, the Great Attractor, the Shapley supercluster, and the Vela supercluster explain the strange flow of galaxies across hundreds of millions of light-years. Despite everything pulling on us, none of these structures pose a danger. We will never reach the Great Attractor or Shapley or Vela. The expansion of the universe, powered by dark energy, is accelerating faster than gravity can pull galaxies together. Eventually, these structures will be pushed so far apart that their influence will fade completely. In the far future, only the galaxies of our local group will remain gravitationally connected, long after everything else is stretched beyond reach. For now, though, we live in a special moment in cosmic history, when these enormous structures are still close enough to study. We can witness the breathtaking flows of galaxies across the cosmic web and see the powerful reach of gravity on the largest scales. Even though the Great Attractor was once a deeply unsettling mystery, it led us to discover even larger and more astonishing structures in the universe. And in the end, gravity itself remains the greatest mystery of all.